So substances undergo changes. A physical change is one where the state or the appearance of the substance is changed, but the composition of it is not changed. So if we look at the example here, we've got a pot with some water on a burner, and we're heating the water. And as you know from experience in life, as you heat the water, eventually it will begin to boil, and you'll see steam coming off of the top. And if you continue to boil the water, all of the water will go into the gas state and escape, and you'll have an empty pot left, right? And you better get it off quick before it gets super, super hot. This is a physical change. The water has changed its appearance and its properties, but it is still water. If we were able to look at the individual molecules, here we have little water molecules. These remind me of Mickey Mouse. Doesn't that kind of look like Mickey Mouse right there? Red face and white ears. So there's a little water Mickey Mouse. And in the gas state, the molecules are exactly the same. Nothing has happened to the molecules. What's happened is they are farther apart from each other. They're in a different physical state. So this is a physical change. The components are the same. A chemical change changes the individual particles. It changes the composition of the substance. So the example given here is an iron nail rusting. So the iron contains iron atoms, and they are in this nice lattice of atoms. So this is a crystalline solid. When iron rusts, it reacts with oxygen and forms iron oxides. So now the composition of this substance has changed. It's not just iron anymore. Now it's iron with oxygen in it as well. And the characteristics of the properties of this matter change. Iron is very rigid and hard. It can be used to build things. You make nails out of iron and you can pound them into something. Rust is flaky, right? And it's not strong. You couldn't make a nail out of rust and pound it into something. You'd have a hard time just getting it to sit there, right? You hit it with a hammer, it's just going to shatter into little tiny pieces. This is a chemical change because the components of the substance have changed. This is a photograph of dry ice suspended in a ring stand. Dry ice is solid carbon dioxide. And a neat thing about dry ice is that it doesn't melt. That's why it's called dry ice. Regular ice is wet ice, because when it melts, it gets wet, right? Dry ice doesn't melt, it goes directly into the gas state. So there's never a liquid associated with it. And that physical change is called sublimation. We'll talk about that later. But the change that's occurring here, in the solid, we have carbon dioxide particles, 2 oxygens and 1 carbon. And when that sublimes and goes into the gas state, we still have carbon dioxide molecules. It's a physical change. It is different now, but the individual particles are the same. Sugar dissolving. Put a teaspoon of sugar into a glass of water and stir it. It seems like the sugar disappears, right? Where did it go? Mystified, right? But if you taste the sugar, if you taste the water, you can tell that the sugar's still there. It didn't disappear, but it dissolved in the water and a homogeneous mixture was formed. Well, this is a physical change. The sugar is different now because it's mixed in the water, right? But it's still sugar molecules. So here we have the sugar molecules. They form a crystalline structure. When we dissolve it in water, those molecules separate from each other, but they are still the same molecules. They're just now mixed with water. So that's also a physical change. Here's an example of a chemical change, a propane burner. So here we have propane. This is what the molecules look like. And when this burns, it combines with oxygen, forming carbon dioxide and water. So here, the particles started out looking like this, and now they look like that. That's a chemical change. The particles are not the same anymore. That makes sense? So chemical versus physical change. has to do with what's happening to the particles. It would be really awesome if we could zoom in like this and actually see the particles. Unfortunately, we can't. So this summarizes difference. No, it doesn't. This is a new thing. This is properties. We were talking about changes. So physical and chemical changes, physical and chemical properties. So physical property is one that can be displayed or observed without changing the substance. So the smell of gasoline is a physical property of gasoline. When you smell gasoline, that does not change what the gasoline is. A chemical property is something that in order to demonstrate that property, you have to destroy the original substance. Gasoline is flammable. That's a chemical property because when you demonstrate the flammability of gasoline, you don't have gasoline anymore because you've burned it. You've got carbon dioxide and water. Other examples of physical properties, again, odor, the taste of something, its color, what it looks like, melting point, boiling point, the density. Those are physical properties. We can observe those without destroying the substance. Chemical properties include things like corrosiveness, acidity, toxicity. In the observation of those, the original substance is destroyed. A chemical reaction has occurred. Okay, so let's see if we can do this. Determine whether each change is physical or chemical and what kind of property is demonstrated in each case. So a copper wire is hammered flat. So what kind of a change is that? It's a physical change. You flattened the wire, but it's still copper, right? So that's a physical change. I'm going to call that PC. What kind of a property is that? That's also a physical property. So we'll call that PP, physical property. That's a property called malleability that many metals have. You can hammer something into a sheet. You can change the shape of it using force. Okay, letter B. A nickel, not the element, but a coin, dissolves in acid to form a blue-green solution. That's going to be a chemical change. CC. When you do that, do you still have a nickel in there? No, it's dissolved. It's gone. The nickel's gone, right? So we've destroyed the original substance. What kind of a property is this? When we demonstrate the property, do we destroy the substance? Yeah. Yes. So this would be a chemical property. Nickel will dissolve in acid. That's a chemical property of nickel. Dry ice sublimes without melting. I'm hearing little whispers. Physical. So physical change and a physical property. These are all going to be the same. If it's a physical change, it's a physical property. If it's a chemical change, it's a chemical property. Dry ice subliming. Okay, this is an example of a state change from a solid to a gas. Anytime you have a state change, it's going to be physical because the component, the molecules or atoms are the same. A match ignites when struck on a flint. Chemical change. Chemical change, and that's a chemical property of the match that it will ignite. You strike the match, it burns, you've demonstrated the property. Can you put the match out and do it again? No, because you've destroyed it. Right? Any questions?